Welcome to fifth grade math tools. In this math workshop, we will take a deep dive into what math tools, the manipulatives and the representations, we should use with our fifth graders to impact their understanding of core mathematical concepts. We will explore why we should provide math tools for our students, what tools to provide, how, and when. Whether you are an educator new to teaching fifth grade, a homeschool parent teaching your mathematician, or an experienced fifth grade teacher. Our hope is that this math workshop will provide support and guidance for you as you teach your children mathematics. To give us perspective into thinking about the math tools to support grade 5, let's look at these 5 domain areas for fifth grade. Operations and algebraic thinking, number and operations in base 10, number and operations in fractions, measurement and data, and geometry. Let's talk about why we should provide math tools for our students. We agree with this quote from Paul Halmas. The only way to learn mathematics is to do mathematics. We believe that providing math tools for students to use in math class offers a wide range of benefits, transforming abstract mathematical concepts into concrete, understandable experiences. Many math concepts like fractions, place value, or algebraic equations are inherently abstract. Math tools provide a tangible way for students to see and touch these concepts, making them more concrete and easier to grasp and to remember. Providing hands-on experience helps bridge the gap between abstract mathematical ideas and real-world scenarios. Math can sometimes feel dry or intimidating. Manipulatives introduce an element of play, exploration, and interactivity, making math lessons more engaging and fun. Increased engagement often leads to more positive attitude toward math, fostering a lifelong love of learning and reducing math anxiety. Not all students learn in the same way. Manipulatives cater to kinesthetic, hands-on, and visual learners, providing multiple pathways to understanding. They are particularly beneficial for students who struggle with traditional abstract instruction, including students who have been performing as low achievers, students with learning disabilities, and English language learners. By building a strong foundation in conceptual understanding through manipulatives, students are better prepared to tackle more complex mathematical concepts in the future, including those in algebra and beyond. Let's examine what math tools can provide a world of difference for in our fifth graders' mathematical understanding of number and lay the foundation for future mathematical connections and concepts. We will explore what tools to provide, how, and when. When looking over the math standards for fifth graders to grasp, we see that providing math tools for fractions and decimals are going to be essential in providing the support with these abstract concepts. In this math workshop, we will examine the tools to provide the conceptual link for understanding fractions and decimals with fraction and decimal models, as well as how impactful number lines can be as a tool for understanding these interesting numbers. Students see the benefits of using a variety of fraction models. Look at all the benefits on the slide for providing fraction math tools for your students, from enhanced conceptual understanding to supporting understanding of equivalent fractions to facilitating fraction comparison and ordering, to aiding in operations with fractions, that's adding, subtracting, multiplying, dividing, to promoting problem solving and reasoning. First, let's review the 3 main types of fraction representations that fifth graders are expected to understand. First, there's the area or the region model. It often gets the most focus in most elementary math classes. Those are the pizza and the brownie problems, the bar model, the circle model, students examining the equal fractional parts of a whole. Next up is the measurement model, also called the linear model, which honestly needs equal time in an elementary math class, but often doesn't get it. Most state math standards expect students as early as third grade to be using the number line or measurement model to place fractions in order for comparing and equivalency understanding. The last main type of fraction representation is the set model. This representation doesn't typically require much focus in a fifth grade math classroom. Typically, it's easier to touch on this concept by just asking students to generate real world examples in their environment. For example, 3 out of 4 chairs at this table group are red, so 3/4 of the chairs are red. Or 9/10 of the students in this group are wearing glasses. Or 8/16 or half of the students on the bus were fifth graders, and so on. Now, let's look at some of the fraction models we want to provide our students with to help them truly understand fractions. Fraction strips. They're produced by many educational companies and typically come with their fractional name pre-printed on each section. The benefit of using fraction strips to support students' understanding of the area or region model is that students can line up the different fractional pieces for easy viewing of fractional size. For example, they can visually see that 1/3 is larger than 1/4. In fact, they can line up 2 1/6s and see that they equal the same amount as 1/3. Fractions can seem so abstract, but being able to put your hands on them and compare their sizes and find equivalency makes fractional understanding come to life. Our favorite fraction strips are produced by Marilyn Burns. In the Marilyn Burns fraction kit, teachers get multiple sets of magnetic, long-lasting fraction strips. They also get a class set of paper fraction strips, multicolored paper fraction strips for students to cut apart, and students then write the fractional names on each piece themselves. Though this activity does take time, the learning and understanding that comes from students actually cutting the fraction pieces and actually writing the amounts themselves on the pieces is invaluable. The kit also comes with a fraction baggie for each student to store their fraction pieces in, as well as a book of fraction games, which they're going to use those fraction pieces that they made in the games, and fraction dice and fraction lessons. Hands-on, it's the best investment you can make for your students. You can order the Marilyn Burns fraction kit from the Heinemann website. Our second favorite math tool are Cuisenaire rods, which can be used to represent both the area region model and the measurement model of fractions. These wooden rods are strategically and purposefully created to represent fractions. For example, a whole could be that orange rod you see on the far right. 9/10 could be the blue rod, 8/10 could be the brown rod, and so on and so on. Or another way of thinking about it is go the other side of the picture with the white small cube on the left. That could equal 1/10. The red rod could be 2/10. The light green rod, 3/10, and so on. The powerfulness of Cuisenaire rods is that the fractional parts are not labeled or pre-printed on there. So students have the gift of exploration and discovery. Through your activities with these tools, you can extend students' thinking for learning other ways of thinking about the fractional names. For example, what if we say, okay, the orange rod is no longer equal to 1/2, but now let's say that green rod that's in the middle, that is equal to 1/2. If that's the case, then how much does the purple rod represent? Cuisenaire rods are such powerful learning tools. Next up are the pattern blocks. These geometric shapes can be used with fraction exploration as well as supporting that area region model. For example, if the yellow hexagon equals one whole, how much does a red trapezoid equal? We would let kids explore. They would come to the conclusion 1/2, because two red trapezoids fit perfectly on top of the yellow hexagon. Again, the powerfulness in the pattern blocks is similar to the Cuisenaire rods. Their fractional part is not pre-printed or pre-labeled on the piece. So we can be flexible in our thinking, which is a habit of mind trait we want to instill in our mathematicians. But what if we spice it up and we say, okay, what if we call the red trapezoid one whole? Then what would we call a green triangle? Again, we would let kids explore and they would figure out that we would call the green triangle 1/3 because 3 green triangles fit exactly on one red trapezoid, if that was our whole. Measuring cups and analog clocks can also be used with fraction lessons, which connect abstract fractions with real life. For example, have your students explore how many 1/8 teaspoons make up 1/4 teaspoon. How many 15 minutes are there in an hour? Students are much more likely to internalize their learning through these types of activities. Decimal models. For grade 5, effective decimal models include base 10 blocks, 100 grid models, and area models to visualize decimal operations with addition, subtraction, multiplication, even division. Base 10 blocks. These blocks can represent ones, tenths, and hundredths, allowing students to physically manipulate and group decimals to understand operations. For example, that yellow flat can represent 1, and a long blue rod can represent a tenth, and the small green cube can represent a hundredth. Like the Cuisenaire rods and the pattern blocks, the beauty of base 10 blocks is that we can provide opportunities for our students to, again, be flexible in their thinking. For example, if we change the one whole to that large red cube, how much does a yellow flat represent now? 1/10? Correct. 100 grid. A 100 grid with each square representing 100th can be used to visualize decimal fractions and perform operations. Shading sections of the grid can represent decimals, and students can add, subtract, or multiply by shading or grouping sections. Decimal circle model is an area model used to help students visualize and understand decimal concepts, especially the relationship between fractions and decimals. It's a type of fraction circle where the whole is divided up to represent tenths and hundredths. You can see that tenths are the larger 10 sections around the circle. Those are the tenths. And the hundredths are represented by, within that tenth, you'll see 10 hash marks. Those are 10 hundredths in each of the tenths. You can print 2 copies of the decimal circle and you cut along the decimal circle from on one of them, from the edge of the circle to the center point, and you can insert that circle into a full circle that's not been cut. And that way you can model how much you're representing with the visual, and your students can do the same thing. Works really well if one of the circles was printed on a color, like in this example, it's purple, and the other one's just white. Then you can really highlight the sections that you're showing. So in this example, it looks like we're almost seeing 2/10. Almost. Number lines. Using number lines in fifth grade offers several benefits for students. They help visualize numbers, especially fractions and decimals, and their relationships, aiding in understanding operations like addition, subtraction, multiplication, and division. Number lines can facilitate comparison and ordering of numbers and can be used to solve problems involving measurement and estimation. One example on this slide shows an open number line, which can be greatly beneficial to students. Teachers will want to model how to use an open number line and share aloud how they're thinking in the problem. For example, for the example that's on the slide, a teacher could say, let's see, I need to figure out how far away is 37 from 85. That's the problem I'm figuring out. 37 plus something equals 85. I know I could add 40 to 37. That gets me to 77. Then I know I could add 3 more. That would get me to a nice round number of 80. Okay, I'm getting close to that 85. I know I can add 5 more from 80. That gets me to 85. How do I find my answer? Oh, I'm going to look at the hops. That plus 40, the plus 3, and the plus 5. 40 plus 3 plus 5 equals 48. Therefore, 37 plus 48 equals 85. An open number line can be a highly effective math tool for modeling strategies for adding and subtracting whole numbers and fractions and decimals. You definitely want to expose your students to number lines and open number lines. Here are the top 4 comments we get from teachers on why they don't use math tools with their students, especially upper elementary teachers. Number 1, we don't have time. 2, I don't know how and why to use them. 3 is probably the most popular. My students can't handle it. 4, I didn't learn that way, so why should my students? Hopefully, this math workshop is helping you with the second comment, providing the rationale for the how and the why. We respect that you are the professional in your classroom, and it is your decision on how to provide the best instruction possible for your students. We want you to consider for comment 1, we don't have time, that your students' time spent truly understanding math concepts through the use of math tools leads to deeper understanding, memory retention of the math concepts because they really understood the math idea. If students don't understand why they're performing math steps or following procedures, it's very likely they will forget what they're doing or why they're doing it or how they're doing it, meaning that next year they won't remember what they learned last year and they're going to have to relearn it again. And additionally, when they don't have that true understanding, they often make lots and lots of mistakes. So our gentle response to the first comment is, how can you not take the time for real learning and understanding? We encourage you to watch this math workshop again and share it with colleagues. We know that teaching is so much easier when we have the support of working along colleagues who are committed to collaboration, sharing, and our journey together in education. For the third comment, my students can't handle it, the next slide will offer tips for successful implementation that teachers have used. For the fourth comment, I didn't learn that way. Why should my students? Our response is that research shows most learners, that's adults and children, learn best through tactile, hands-on, and visual experiences, especially in mathematics, where the concepts tend to be very abstract. Here are the tips for successful implementation of math tools from teachers. Number 1, give students explore time. every time. And we're just talking maybe 2 minutes. Set a timer, tell your students, we're about to use this object as a math tool, but first, I want to respect you and your time. Here's 2 minutes of explore time. It's your time to check out this tool before we use it as a math tool. And you will find that students will appreciate this explore time to see what the tool feels like, what it looks like, what they can think about or build or how it moves. Then, when it's math tool time, they're able to focus. Number two, set very clear expectations. Before ever passing out a math tool, share this is what it is, this is how it can be used. Most importantly, this is how it will not be used. For example, with geoboards and rubber bands that are often used, share with students. Rubber bands will not go flying across the room. If they do, share the consequence that students will lose the opportunity that day to use the math tool, and they only will be able to watch others. Students do not want that. Number three, model usage. This is how we're going to use the tool today. Number four, consider options that work best for your budget, your space, and your students. Do you want to provide a math toolkit for each student where items inside rotate over time and students have choice in choosing which math tool to use to help them solve or model a problem? You could have a classroom helper job to restock the math toolkits regularly. Kids love doing that. Or would it work better in your space and with your budget to have a math tools area in your classroom with math tools in plastic bins? Possibly consider having table group or individual student amounts in a baggie, whatever works best for your activity. Our hope is that this math workshop supported your understanding of the math tools your student will benefit having their hands on. In essence, math tools are not just supplementary aids. They are essential components of an effective mathematics education, empowering students to actively construct their own understanding of mathematical ideas. Additionally, if you are more interested in more support, we invite you to join the fifth grade math workshop community. This is a private community of other fifth grade educators. You will receive monthly emails of math workshops taking a deeper dive into the math standards for your grade level, as well as grade level activities, lessons, rich mathematical tasks and investigations, games, and support for your math instruction for your students. You can learn more at our website, themathworkshop.net, on our resources page. Click on your grade level. Thank you for your time, and we wish you a terrific year.